Welcome to the 17th episode of Byte-Sized JavaScript. In the former episode, I said that we were going to talk about some JavaScript fundamentals. And before we do that, I wanted to interject some useful tools and concepts such as cloud development environments, unit testing, and continuous integration in the cloud so that we can have a more solid baseline. Having your development environment in the cloud has its own advantages. First of all, you won't need to deal with IDE setup and configuration all the time. So for instance, if you have purchased a new laptop or if you want to work on your friend's machine, you don't need to download and install software to get you started. You can just launch your Cloud IDE in the browser and then you'll be all set. Secondly, cloud workspaces are sandboxed. So for instance, if you install a certain version of a build tool or a runtime for one of your projects, and you are working on a totally different runtime and totally different setup for another project, you can use a separate cloud workspace and they won't affect each other. So basically you get a separate Unix container or a separate virtual machine for each and every single one of your projects. And also some of the cloud IDEs have collaborative coding feature, which is very useful when you have a distributed team across the globe and you want to do some pair programming so that you can share your workspace together and collaboratively code together in the same workspace even though you are not in the same physical location. Additionally, you can have real-time debugging support for most of the languages. And last but not the least, cloud IDEs save power. Since they run on the browser, they consume much less juice than their traditional counterparts. So if you are working on your laptop and you don't have immediate access to a power outlet, like if you are working on a bus or in a train or in a plane, then using a cloud IDE can provide you with some extra time to get things done. So if you can compromise the comfort of a full-blown desktop IDE, then cloud development environments have many advantages to compensate for it. When it comes to cloud IDEs, there are a lot of options that you can pick from, like CodeEnvy, or Coding, or Code Anywhere, or IceCoder, or Cloud9. And they have many different features to compare and contrast. So what I suggest is before settling down with a certain cloud IDE, try at least a bunch of them and see which one fits your needs better. Most of the cloud IDEs provide more or less a similar set of features, and most of the time, to be honest, it will all boil down to your personal taste. So just try a bunch of them and then decide. If you ask me, my personal cloud IDE of choice is Cloud9. And from this point on, most of the time, I'll be using Cloud9 IDE in our screencasts. And to do that, I'll first clone all of the Byte-Sized JavaScript repositories that we have created so far in my Cloud9 workspace first. And as you see, it's a pretty straightforward copy and paste process. And now that I have copied them all, I'll show you some of the features of Cloud9 IDE and also try to give you a taste of how it feels like working in a cloud development setup. So first I'll open this Byte-Sized.tv repository for instance, and as you see my development environment is exactly how I left it off last time. That's one of the features that I like about cloud IDEs. Your IDE will look exactly like how you left it off. Let us close all these tabs from the previous session and start with a clean slate. And as you see, I'm in a browser and this is a cloud IDE. And I have a Linux container in the cloud, so I can run Linux commands in my container or install any programs or utilities that I might need through the operating system's package manager. For example, our node.js version is 4.6.1 and I want to upgrade it to a more recent version, so I can just do a npm install 7.1.0 for instance to install node.js version 7.1.0 in my system. Next, let's install the dependencies of our project by doing an npm install. And then I'll execute npm run watch build so that my code is transpiled whenever I make a change in the source files. I'll also put a breakpoint here to show how breakpoints work in a cloud IDE. And we'll soon see how to use that breakpoint by creating a runtime configuration. And in another tab, I'll execute npm run serve to launch a very basic HTTP server. Now I can go to preview running application, and preview this application inside the IDE. And I can also copy this URL and preview my running application inside another browser too. Now I'll slightly update this fetch script to source the correct API keys. And when we look at this line, there is obviously a problem with it. For one, this environment uses Bourne shell, and to source in Bourne shell, you use a dot notation instead of this source command. And there are other minor fixes to make this script work as well, and I'll fix them offline later since it's not the main topic of this episode. What I want to show you instead is how you can debug your JavaScript inside this Cloud IDE. For this, I'll go to Run Configurations, and then select New Run Configuration, and then enter node bin fetch.js as the run command. Also note that you can set the current working directory for this configuration, and you can also set a bunch of environment variables to pass to the script that you are running. And when you press this green tiny little bug icon, Cloud9 will run your script in debug mode and it will hit the breakpoints that you have set beforehand. So let's run our script by tapping this green play button and also put a breakpoint inside our transpiled code. Since Cloud9 doesn't have source maps integration yet, we can only debug the transpiled code, and it's not so bad. You'll see that it's fairly easy to step through the transpiled code too. So when we run our script in debug mode, we'll hit the breakpoint that we set. And as in any good debugger, you can step in, step out, step over, and see how your context looks like when the code reaches your breakpoint. So that's briefly how Cloud9 IDE works. Now let's create a new project from scratch to see how this entire cloud development workflow looks like. We'll name our project Badem, because why not? And Badem will be a higher order component composer that can compose abstract components without necessarily needing a document object model. I know at this point that doesn't make quite a lot of sense, and don't worry, that's not the point of our talk anyway. My goal is just to show you how developing in a cloud environment feels like. I'll give the workspace a name and also specify the URL that I'm cloning it from, which is the Git URL that I just copied. And that's the only thing that I need to create our initial workspace. Now let's add some files to it. So what this module will essentially do is to consume a JSON that slightly looks like an HTML tree with nodes and nested nodes and children and attributes and stuff like that. And we'll traverse that tree recursively and then take actions based on which node we are at. So let's move this to the right of the IDE so that we can compare and contrast it with the rest of the code that we'll be writing. I'll also create a module called store, and this store module will have a corresponding function for each of the possible node types that we have in our JSON tree. So these functions will either return a node instance or they will return a promise that will eventually resolve with a node instance. And to make the promise use case more realistic, I'm setting a slight delay by wrapping this resolution function inside a set timeout. Now let's export a mount function from this module, and the mount function will traverse this JSON tree and eventually it will generate a hierarchy of more concrete objects. We will pass this function a component store instance, which is our store module, and also a descriptor, which is our app.json as you see here. And I'm going to fast forward this part because after all, the point of this episode is to give a feeling of how cloud IDEs work. It's not to discuss the entire code flow, which probably will be the topic of another episode. So let's move on. This module will be used in a JavaScript runtime that does not fully support ECMAScript 7. So in order for it to be consumed properly, I'll have to transpile and bundle the source code. And for that, I'll be using Webpack. Webpack, as you may know, is a module bundler, and I won't dive into the details of how Webpack works right now. I'll probably cover it in a separate episode. So if you want to learn more about it, you can follow this link and get more information. So I'm going to create and configure my webpack.config.js, and before that I'll need to install my dependencies, and even before that I'll need a package.json. So let's do an npm init to initialize our module. And now that I have a package.json, I can install Webpack and its friends so that I can transpile and bundle my JavaScript code. And of course, to be able to transpile stuff, I'll need to install Babel and its friends too. And that might feel like an overkill initially, though the more you do this, the more you get used to it. And there are even starter kits, boilerplate projects, and code generators that you can use so that you don't have to manually figure out and install all these dependencies to just get yourself going. Anyway, since we are installing helpers, let us also install a linter, ESLint. And again, we'll have to install ESLint and its friends as a group to be able to run it in our project properly. And before I forget, I'll also need to install this Babel polyfill so that I can use things like promises and other useful JavaScript constructs in case our JavaScript runtime does not natively support them. Then I'll freeze the version numbers in my package.json so that my project will behave more deterministically. I find fixing version numbers like this a safer option for production environments, especially if you are working with open source a lot and you are using some cutting edge features and technologies. Some of the modules that you depend on might occasionally introduce breaking changes when they should not, and by fixing version numbers you make sure that any possible breaking change does not leak into your production code. But this approach has its consequences as well, because when you fix the version numbers, you lose the ability to automatically catch up with the updates and security patches and bug fixes that are done on the library. So you need to trace those dependencies and regularly upgrade them and test them in a testing environment. But that's not a big deal after all. It's a trade-off that most of the time you can make. And after installing all these dependencies, we can finally create our webpack.config.js. Without diving into too much detail, what we are doing here is to tell Webpack to take everything from the source bucket, transpile them, and bundle them into this destination bucket so that it can be consumed in legacy runtimes. I'll also create a script to automate this process so that we can execute npm run build node to build the dependencies for a node.js runtime, for instance. And when we execute npm run build, we actually generate our bundled files inside this dist folder. So far so good. Now let's write an example script to test our module. But before that, it looks like we forgot to add this babelrc file. So let's add it so that we can transpile our files properly and then rebuild our dependencies. And also we'll need to properly format this JSON so that we can include it as a module. And finally, we need to export our store module so that our mounter function can consume it. So let's rebuild the application and run the test module. And yay, it looks like we are getting some output in the console. And when you compare the output that you see here with the JSON tree that we have there, you'll see that we are recursively mounting all the objects you see in the JSON schema one by one. So the code appears to be working properly. Next up, we'll define some ESLint rules. And actually, we'll probably want to share this rule set across other projects that we develop. So let's copy this and move it into its own repository, jsbytes/coding standards maybe. And I'll also create an npm package for that and then publish it to the npm registry. And instead of putting a large chunk of JSON into my configuration file, I can simply extend from the JSBytes coding standards module in this case, which will make our code drier. Also, we should not forget to install the coding standards module so that we can consume it. And let's also add a linter script and modify the package.json so that when we run the test, we first run the test and then run the linter. Perfect. And when we do an npm run lint, we get a bunch of warnings, which is good so that we can fix them. Let's fix these linter warnings and move on. And now we don't have any warnings remaining, so we should be good. Remember, in ESLint, no news is good news. And as a final step, we'll add our repository to a continuous integration or a CI environment. And for the CI environment, we'll be using Travis. To be able to add our repository, we'll first click here and add a repository, then refresh our view by tapping this sync account, and then enable this tiny little switch for our repository. And next, we'll need to create a travis.yaml as you see here, and then push our changes. And let's also add anything that we have under this dist folder to gitignore. We only need them in our npm packages and we don't want them to be source controlled. And I'll just do some final changes before I push the source code. So let's push the code and go to Travis, and as you see, it already started building on your branch. And it looks like our build finished successfully, which I was not expecting because our test script was explicitly designed to fail in the first place. So we'll do 3 things to fix this behavior. First, we'll install Chai and Mocha to our workspace so that we can write a proper unit test. And to do this, we'll do a npm install mocha chai --save dev. And then we'll write a basic Mocha spec. And finally, we'll fix our test script so that it terminates with a proper exit code whenever our tests or our lint checks fail. And to verify this, first let's intentionally make our Mocha spec fail and observe in the console that our npm run test fails and our script exits with a proper exit code and a proper message. And then trigger a lint warning. And after that, trigger a syntax error so that our linter fails, and observe that our test script again exits with a proper exit code and a proper message again. So it looks like our code is ready to be pushed. Let's push it and see how Travis build responds. Alright, our build failed again because our test script also needs to build our node.js dependencies as well. And let's add that part to the test script as well and push our code again. And now our build is green. Since our build passes, I can tag this successful build and then publish it to npm. And after publishing our module to npm, we can go to npmjs.org and we can see that our package has been published successfully. So yay! And you'll also see that even when we tag a new release and push the tag, it will trigger a new build in Travis, which is the whole point of continuous integration. You should be treating everything you push to the source control as production ready. Anything you commit, push, or merge to the source control should be passing tests, and your build should be green after every push. In the end of the day, green is good. And that concludes our episode. Wow, that was a long one. I hope I didn't spread the topic too much. To summarize, in this episode, we have looked into cloud development environments in general and Cloud9 IDE in particular. We talked about the benefits and liabilities of using a cloud IDE. We learned how we can debug a Node.js projects inside the Cloud9 IDE, and then we created a new project inside the Cloud9 IDE from the ground up. We enabled transpilation, bundling, linting, and unit testing for this project. We briefly mentioned webpack. We wrote npm scripts to lint and test our project, and we created a simple unit test with Mocha and Chai. And then we integrated our tests to a CI environment, which is Travis. That was a lot to digest in a single episode, and I hope you had fun. I just wanted to take this off of my chest so that in the next episode I'll be able to talk more about JavaScript fundamentals as I promised. And a promise is a good segue to what we are going to cover in the next episode. In the upcoming episode, we'll be talking about promises, and you'll see different ways of managing and controlling the flow of information in your applications. And until then, may the source be with you.